Hi, I'm Kesida, studied in CSCA section Ashankara Institute of Technology. I'm explaining about topic is NP completeness. General problems in input size and time complexity. Time complexity of algorithm, polynomial time algorithm, efficient algorithm versus exponential time algorithm, inefficient algorithm. In this diagram table, n fn by n 10 30 50 n equal to 0.0001 seconds, 0.0003 seconds, 30 minutes, 50 which is 0.0005 seconds, n power 5 0.1 second, 24.3 seconds, 5.2 minutes, 2 power n 0.001 second, 17.9 minutes, 35.7 years. Hard and easy problem. Sometimes the divided line between easy and hard problems is an fine one. For example, find the shortest path in the graph from x and y. Easy. Find the shortest path in graph from x and y with no cycle. Hard. View another way as yes or no problems. In is there is a simple path from x and y with the weight greater than or equal to m. Easy. Is there a simple path from x and y with weight less than or equal to m? Hard. First problem can be solved in polynomial time. All times algorithm for a second problem could take exponential time. Decision problem. The solution to the problem is yes or no. Most optimization problem can be formed as decision problems still have to the same time complexity. Example, assume we have a decision algorithm x for 0 by 1 knapsack problem with capacity m. Algorithm x returns a yes or no to the question is there is a solution with profit less than or equal to p subject to the knapsack capacity less than greater than or equal to m. We can repeatedly run algorithm x for y various profits p values to find an optimal solution. Example, use binary search to get the optimal profit. Maximum of LG than equal to p times, where m is the capacity of the knapsack optimization problem. Minimum bond, optimal profit, maximum bond. The classes of P and NP. The class P and deterministic Turing machine give a decision problem x if there is a polynomial time deterministic Turing machine program to the solve x, then x is belong to P. Informally, there is a polynomial time algorithm to solve the problem. The class P and non-deterministic Turing machine give a decision problem x. There is a polynomial time non-deterministic Turing machine program that solve x. Then x belong to NP. Given a decision problem x for every instant of x, guess solution yes for I and check is yes a solution to I. If a and b can be done in polynomial time, then x belongs to NP. Observe in this diagram p is equal to NP, that is a decision problem is does not need a solution. The correct solution can be computed in polynomial time. Some problem which are in NP but many not in 0 by 1 knapsack problem. Partition problem give a finite set of positive integers z. Question, is there a subset z of z such the sum of all numbers in z, sum of all numbers in z minus z1. One of the most important open problem in theoretical computer science is IP is P equal to NP. Most likely, no. Currently, there are many decision problems in NP and there is no solution to show any one of them in NP. NP complete problems. Stephen Cook introduced the notation of NP complete problems. This makes the problem P equal to NP much more interested to study. The following are several important things present by Cook. Polynomial transformation L1 and L2. There is a polynomial time transformation that transfer arbitrary instance of L1 and some of L2. If L1 are equal to L2, L1 is the P implies L1 is in P, or L1 is not into P implies L2 is not P. If L1 is equal to L2 and L2 equal to L3, L1 equal to L3. Focus on the classes of NP decision problem only. Many interrogative problems when faced in the decision problem belong to these classes. L is NP complete. If an NP complete problems can be solved in polynomial time, then all problems in NP can be solved in a polynomial time. If a problem in NP cannot be solved in polynomial, then and all problems in NP cannot be solved in polynomial time. Note that NP complete problems, one of these hardest problem in NP. L is NP hard. NP hard problem is problem which is an hard as an NP complete problems is necessary to an decision problems. To see the diagram, so the NP complete problem is NP, then P equal to NP. If P equal to NP, then all NP complete problems are in NP. P. How can be obtained to first NP complete problem in L? Cook theorem. Searchability of is NP complete. The first NP complete problem instance give a set of variables U and collection of clashes. C. Overview questions. There is to the segment of U a statistic of calculations in C. Example in this problem. The Cook's theorem, we have to following the property lemma. If L1 and L2 belongs to NP complete, and L1 is equal to L2 is NP complete. So now to prove the decision problem L to be NP complete, we need to show L is in NP. Select an NP complete problem shall construct to polynomial time transaction F from L to L. Prove the correctness of is has a solution if and only if L has a solution and that F is a polynomial transaction. Show the diagram. P. Decision problem solved by a deterministic algorithm in polynomial time NP. Problem solved by a non-deterministic algorithm to polynomial time. A group of decision problems include all of the waves we have to discuss satisfied by 0 and abstract longest path partitions have a additional 10 property. If any of them can be solved in a polynomial time, then they all can be. These problems are called NP complete problems. Thank you to all.